So lesson 8.3, adding and subtracting rational expressions. This is just like when you are adding and subtracting fractions. And to add and subtract fractions, we must have what? A common denominator. So when we add rational expressions, we must also have a common denominator. And then this one also is asking us to identify x values for which the expression is undefined. So if our denominators are the same, then we write our numerators. So here we have x minus 3 plus x minus 2 over x plus 4. So we can write it as a single fraction, and then it's just a matter of simplifying it. Now, the one thing you need to make sure of is after you simplify it, you do need to check just to make sure that your answer, okay, cannot be simplified further also. Okay, that there isn't any factoring that can happen and cancellation. And the numerator 2x minus 5 and the denominator of x plus 4, they have no common factors, so I can't simplify that. Now, you always have to be careful when you're subtracting, though. Okay? Subtracting is what throws a lot of people off. And so you actually have to take one extra step when you do your work, just to make sure you're doing it correctly. So here we do have a common denominator of x squared plus 1. So in the numerator, I have 3x minus 4 minus the quantity 6x plus 1. Now, I want to make sure that I put minus that whole quantity, because you got to remember that it affects the whole thing. So you're better off to actually write it like that first of all, go the extra step so that you don't make a mistake of forgetting to change a sign. So then this is 3x minus 4. I distribute the negative, so I get negative 6x minus 1 over x squared plus 1. So I'm going one extra step here. I'm actually going to do this step here to where I write minus that quantity just so I don't forget to distribute the negative sign. So then my final answer would be negative 3x minus 5 over x squared plus 1. So where is this undefined? Plus or minus 1? Okay, let's try that. All right. So if I put in 1 for x, okay, in the denominator, we get 1 squared plus 1, right? What's that equal to? That equals 2, doesn't it? Lauren wants it to equal 0, but in reality it equals 2, doesn't it? Okay. So what if we put negative 1 in here? What do I get when I square a negative 1? 1. And 1 plus 1 is 2 again. So these both equal 2. So there is no values where this is undefined. So this answer then is just what I've got there. Okay, so that is the answer. It's defined everywhere. Okay, and let's show why that is too. Let's do a little graphing for a second. Go to my y equals, and if I graph x squared plus 1. Never equals 0, does it? Okay, so if it never equals 0, then the denominator is never going to be 0, so I'm okay. Right? So with your denominator equal to 0, anytime you have x squared plus a number, there's never going to be a 0 there, so you don't have to worry about zeros in that case. Okay? Because it can't be factored. If there's no zeros, it can't be factored. Okay. Least common multiples. Well, with getting common denominators, you actually need to work with least common multiples to do that. And when we talk about least common multiple, we're talking about the smallest thing it takes to go into it. Okay? But in reality, in some instances, it's the most. Okay? So it's kind of a little confusing. So it's to find the least common multiple, factor each polynomial completely, write any repeated factors as powers. For example, if we have x cubed plus 6x squared plus 9x, we'll write that as x equals the quantity x plus 3 squared. Then step 2, we'll list the different factors. If the polynomials have common factors, use the highest power of each common factor. Okay, it's simpler than that, but we'll talk our way through it. Right? So for letter A, we have 4x squared y cubed and 6x to the fourth y to the fifth. Now, the reason we're finding least common multiple is because we're saying that these two things would be our denominator, and what would make our common denominator with those two things. Okay? So we need to find the smallest number that 4 and 6 go into, all right? The smallest term that x squared and x to the fourth go into, and the smallest that y cubed and y to the fifth go into. So the easiest way to do this is, all right, we'll think our way through it. Okay, what's the smallest number that 4 and 6 go into? Okay, now it's not 2. Okay, 2 is the smallest number that goes into them. I want to know the smallest number that they go into. So if I list the multiples of 4 and the multiples of 6, what's the smallest one that they both go into? 12. Okay, so 12 is the least common multiple of 4 and 6. Okay? When it comes to variables then, it's just the highest powered variable. So in this case, it would be our least common multiple would be 12, x to the fourth, y to the fifth. And we could write that all out a little bit different way, but I think for the most part, if you just think of it that way, okay? What's the smallest multiple that 4 and 6 go into? All right, the smallest number they go into. And then when we're talking about the variables or something with powers, we're just looking for the highest power then. Okay? So x to the fourth and y to the fifth. So here in letter B, we're looking at, these would be our two denominators. And we want to find a common denominator. That's the object of finding the least common multiple, is being able to find a common denominator for them. So what we want to do is we want to factor them. So our first task when we have polynomials is to factor. Now, after you factor, all right, so let's write this down. Number 1, factor. Number 2, list all different factors. Okay, so we factored it. Now we're going to list all the different ones. So we have x minus 3, x plus 1. Now there's an x minus 3 over here too, right? But I already have x minus 3, so I don't list it again. And then x plus 2. Now, look at the degree of all those factors. The degree of all of our factors is 1, right? Okay. The degree of all the factors is 1. So, do I have all of them represented here? Okay. Now, the third thing is then, is after I list all the different factors, then I want to use the highest power of each. So I list them all, then we use the highest power of each. And if you notice, the highest power of all of them is 1. So that means that this is my least common multiple. I factor, list all the different factors, and then use the highest power of each one. So for instance, if it happened to be that this was a 3 here, okay, x minus 3 to the third, then that means I'd have to have a 3 here. Okay, so I would still have x minus 1, or x minus 3 in both of these two. So I've listed all of them, but I have to make sure I use the highest power. So the highest power would have been 3. So that is my least common multiple. So now that we can find the least common multiple, that means that we can find the least common denominator, which is what we need when we are adding rational expressions that do not have a common denominator, and we need to find one. So when you're trying to add or subtract, when we get there, rational expressions with unlike denominators, the first thing we want to do is factor the denominators, if we can. So in this case, we want to factor this side. We have x minus 1 and x plus 4. And usually, not always, but usually, if the other fraction or the other expression has just a single denominator, like the x plus 4 here, usually the other one's going to have 1. Not always, but most of the time. So I look at my denominators. Look at the one on the left in factored form. Look at the one on the right. Okay. They have x plus 4 the same, right? The one on the left has x minus 1. The one on the right doesn't. So I want a common denominator. So that means then that I need to multiply this other denominator by x minus 1, but I also have to multiply the numerator by x minus 1. And how come I have to do it to the numerator also? What's x minus 1 over x minus 1? 1, okay? All right, it equals 1. So in reality, all I'm doing is multiplying by 1, which changes the way it looks, but it doesn't change the value of it. So now I have x minus 3 plus 2x times x is 2x squared, and 2x times negative 1 is a negative 2x. And then that's over my common denominator of x minus 1 times x plus 4. Okay, and then we simplify it. So we get 2x squared minus x minus 3 over x minus 1 times x plus 4. Now we need to check to see if I can factor the numerator, because maybe now I might have a common factor in the numerator and denominator where I can simplify this even further. Okay. So now we need to factor the numerator if it's possible. So let's see what happens if we do that. Well, here's the thing. Okay, here's what I want to check. Right. The only way it's going to help me is if I have x minus 1 in the numerator because I have it in the denominator, right? Okay. Because if I have minus 3 here on the end, this 4 down here, there's no way that's going to be common, is it? All right, so we're going to try something. This is what you can do. All right. Now, number 1, you can just go ahead and factor it. But number 2, what you can do is I can make x minus 1 one of my factors. Okay. So now I need to see if my other factor then, if when I would multiply them, they would agree to this. So this would be 2x plus 3, right? Okay. X times 2x is 2x squared. Negative 1 times 3 is negative 3. Okay. Now, does this factorization equal my trinomial here? Now let's see. We know we have the first and the last terms are correct, but does the middle term, does positive 3x minus 2x equal negative x? Okay. Now let's see, I get positive 3 here, and negative 2 here, and 3 minus 2 is positive 1, not negative 1, right? So if I was to factor this, then my factorization in reality would be where it would be plus 1 here and a minus 1 there then, right? It should be negative 3 and positive 2, which that does, so then, let's see here. These two then are not the same, so I can't simplify it anymore. All right, so then my answer would be 2x squared minus x minus 3. And I'm going to write this denominator then as a trinomial instead of as factors. X squared plus 3x minus 4. And values where it's undefined. X cannot equal 1 or negative 4. So you have an option, okay? And, you know, some people like some of those little quirky things that they'll do. Some people don't, okay? But, so what I need to do for sure, though, is you need to factor the numerator then and see, is there any thing I can cancel? If there is, great. If there's not, then I'm done. Okay? All right, so let's try another one. All right, so I look at my denominators. They're not the same. So I factor any of the denominators that can be factored. So in this case, they both have x plus 2, but the left side does not have x minus 2. So I need to multiply the left side by x minus 2 over x minus 2. So we multiply x by both of those parts. So we get x squared minus 2x and minus 8 over x plus 2 times x minus 2. Then factor the numerator if you can. Let's see. What do I get when I factor the numerator then? Okay, minus 4 and plus 2. So x minus 4 and x plus 2 over x plus 2 times x minus 2. Oh, so now we do have a common factor. So I can cancel the x plus 2's, and my final answer will be x minus 4 over x minus 2. And don't forget, where is it undefined? And it's undefined from the original, not from my answer. So x cannot equal a positive or a negative 2. You have to use both. You have to go back to the original, not from your answer. Okay, let's do one subtraction. And subtraction is just like the adding. There's only one difference that you need to be careful of, and that's because of that minus sign between them. And just like we did one extra step when we're subtracting with a common denominator to begin with, when we have unlike denominators, we also want to make sure we take that extra step just to be careful about distributing the negative sign. Okay, so once again, we'll factor the denominators first if they're not the same. So our left side is x plus 3 times x minus 3. So what does the left side have that the right side doesn't? Okay, the x minus 3, so we'll multiply numerator and the denominator by x minus 3. Now, this is where you really need to be careful, because here's what I'm going to do. I'm going to put my minus sign here, and then I'm going to make put a parenthesis, because it takes me a little bit extra work, but I'm going to make sure that I get the answers correct. And then I'm going to FOIL. X squared when I do negative 3, positive 5, so plus 2x and minus 15. The middle term, 5 minus 3 is 2. Okay. So now then, I need to distribute that negative sign. Okay? The minus in front of the parentheses, we need to distribute that. So we have 2x squared minus 30 minus x squared minus 2x and plus 15. It's an extra step or two, but I need to make sure that I distribute the negative. I mean, if you can think your way through it, that, okay, when I do this, when I FOIL up here, because I have the minus in front of it, when I write my answers down, I need to write them down as the opposite. If you can think your way through that, that's fine. But I would take the extra step just to help you out. So when we simplify, we get x squared minus 2x minus 15 over x plus 3 and x minus 3. And then I can factor in this case. So if I can factor, I will. So the numerator is x minus 5 and x plus 3. So this can be simplified further. So my answer is going to be x minus 5 over x minus 3, and x cannot equal plus or minus 3. Okay, so one last thing then. Here we have, notice what we have here. We have a fraction divided by a fraction. So what are you supposed to do when you have a fraction divided by a fraction? Copy, change, and flip. Just like we did when we were multiplying and dividing, all we're doing, we're dividing again. So we're just going to copy, change, and flip here. So x plus 2 over x minus 1 times x plus 5 over x minus 3. And then if we have common factors, which in this case we don't, if you have common factors, you'll cancel those common factors. If not, then in this case, my answer is just going to be that. So all this is exactly like what we did with the multiplying and dividing. It's just written a different way. So it's just a fraction